So a little while ago, I posted the first video in this ongoing project, Autonomous Agriculture, where I'm basically just trying to find all the ways I can automate my garden. In that video, I showed a system I built which basically just takes soil temperature data from my garden and uses it to tell me the best time to plant. I also mentioned that that stage of the project was really just a rough draft and that I plan to redo pretty much everything. So that's what this video is about. It's really just an update to that last one. Just a quick warning, this video is pretty much just about software, so if that doesn't interest you, I don't blame you for clicking away. But you should stay tuned because the next stage of this project is gonna be a lot more interesting. So the first decision I had to make when redoing this project was what software I wanted to replace Excel with, and for that I chose Python. I chose it mainly because I don't have a lot of experience with Python and this seemed like a pretty good opportunity to get some. It's also a really good choice because Python is really flexible with a ton of different software modules, which will make this a good foundation to expand on later. Speaking of software, I have all my code here in this GitHub repository, which you can check out in the description. I'm just going to give a quick overview of each of the different components so we can see what's different from the draft. We can start here in this folder web app, which stores all the code for the front end that I interact with as a user. For this part, I chose to use a software module for Python called Flask, which is really nice because it allows us to write web applications without knowing JavaScript, which isn't really something I'm interested in learning. Basically just initializing a Flask app, doing a bunch of configurations, and using the blueprint functions to enable us to have a bunch of different pages. We can see here what that looks like. I have a home page which displays the most recent photo taken by my Raspberry Pi camera. And we have a menu here which allows me to separate all the different functions of my app. If we go to the settings here, we can see that I have some of the same functionality that I had originally with Excel. To accomplish this, I'm using another software module called Dash. Dash makes the process of interactive dashboards in a web application really easy with Python. What's cool is that under the hood, a Dash application actually uses a Flask server to do all the web application stuff. This means that we can actually integrate the Dash apps with the Flask app by just passing in the Flask app that we already have whenever we initialize a new dashboard. We have this Dash application here which allows us to recreate the interactive functions of Excel. For example, I can come here, I can change the minimum temperature, I can submit these changes, and if I refresh the page, it's gonna still be there. And we can do this while having multiple Dash apps integrated into the same Flask server. I can come here and I can click this drop-down menu, and here we have another dashboard. This is the code that manages the Flask blueprints for that page, and we can see here we're really just converting that whole Dash app into HTML and then passing it in. This makes it really easy to expand this project because all I have to do is add another dashboard, though this probably does have performance implications in the long term. Using Dash is also how I recreated the calendar functionality in the Excel application. Here we can see that we have a calendar that's pretty similar to before. It has much of the same functionality, though it probably doesn't look as clean as the Excel version. I wasn't able to get the temperature representation on the same graph as the planting calendar, so it's on its separate page. It doesn't look as nice as having the colored cells like in Excel, but it has the same functionality. Each of these numbers just represents how many degrees of temperature variation are outside the preferred range for the plants. Dash also allows for some pretty nice data visualization. Here's the graph of the soil temperatures in my garden just for this year. There's a lot of nice little things about Dash, like this date range picker that I can use to not only view the data for this year, but I can also view all the data that my sensor has collected so far. I can even see these visual trends in relation to the actual preferred temperatures of my plants just by putting it on the graph here. I have this whole dashboard that allows me to see a visual representation of all the harvests I've had this year and in total. We can also see this data in terms of calories. For example, here we can see that potatoes and sweet potatoes made up 10 and 8% of the total mass of my harvests. But if we switch to calorie mode, we can see that potatoes and sweet potatoes made up 30 and 18% of the total calories. I just want to be clear that none of this data is remotely necessary at all. I really like data. So going back to the repo here, the next section we can look at is this local app. This section handles the Internet of Things side of this project that talks to my different microcontrollers. I just have an MQTT server that plays the same role as the Node.js server in the last video. Whenever it receives a message from my soil sensor, it takes all the values and puts it into the database. Speaking of the database, for this project I chose to go with a combination of SQLite and SQL alchemy. SQL is an acronym that stands for Structured Query Language, and it's basically just a type of database that stores data in these nice tables. SQL Alchemy is a Python library that really just streamlines the process of querying the database. Here we can see that all the data I need for these projects is stored in these models, and every time I need to make a new entry, I just make a new model and add it to the database. These tables, along with the Dash visualizations, allowed me to recreate pretty much all the functions of Excel that I needed. In terms of the microcontroller code, there's not much to say here. I organized all the code into different files. The code does pretty much everything that it did before, except it's rewritten to use the string class and the MQTT server. In addition to the code, I printed another lid for the case, and this time it didn't break. I also mounted it directly into my garden at a 45-degree angle for maximum sunlight. I now have all the code in this repository, which is linked in the description, so check it out and feel free to ask me any questions if you're interested. Like I said before, the next stage of this project is going to be a lot more interesting. I have a valve here, and I have another ESP8266, so stay tuned for that. As always, let me know in the comments if you have any ideas of where I could take this project in the future. But until then, thanks for watching, and peace out.